Testing, testing. Can someone see the slide?
Yes, doctor.
Yes, doctor.
Oh, you can see the slide. Okay, now I can see the slide. Adrina, can you quit for a while and then join again?
Okay, doctor.
Because you are now host now. I think there is technical
Yes.
issue.
Yes.
Yeah. Can you leave for a while and join again?
Okay, doctor.
Right. Okay. Thank you. Thank you. Okay. Bismillahirrahmanirrahim. Can you hear me? Is it?
Yes, doctor.
Yes, doctor.
Okay. Let's begin. Okay. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil mursalin wa ala alihi wa sahbihi ajma'in. رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي اللهم لا سهل الا ما جعلته سهلا وانت تجعل الحزن اذا شئت سهلا. Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. So how are you guys? Are you okay?
Doctor.
Good, doctor.
Good, doctor.
Right. So let's proceed to the next lecture 3. I have to give lecture quickly because right now is in week 4. So supposedly should be lecture 4. Okay, but at the moment we are still in lecture 3, still not yet start. but we'll go quickly later on. So lecture 3, it is about particle gain, but it is in 3D, three-dimensional, okay? Resultant and equilibrium in 3D. So you will learn about resultant and also equilibrium system for 3D particles. So previously you have learned about 2D only, resultant in equilibrium, and right now we have 3D, which is 3 axis involved. Okay, what you will learn for today, the first one is force components. So since we do have a 3 axis, then we do have a 3 components, x, y, and z. Okay, you will learn the force components. Number 2, you will learn on how to do analysis. Once you have the problem, you have to do some analysis. You have to solve the problem. Okay, we do have 3 different methods. The first one is first angle method. The second one is the second angle method, and the last one, the coordinate method. Okay, so number 3, you will learn on the resultant. Yes, you will calculate the resultant, the total force, okay, in 3D for particles. And the last one is equilibrium in 3D for particle. Okay, we apply the first Newton's law, okay, to meet the equilibrium system. Okay, if you can see the application of static in biology, in human, so this is the thing that you can see right now. Okay, so we apply static or we apply biomechanics element to study the behavior of human, for example. Okay, we can see the forces that acting on the hip joints. We can see the forces, we can estimate the forces that acting on the ankle joint. Okay, so for example, this point, okay, we can see the forces, internal and external forces that acting on this ankle joint. Okay, and you can use the static principle to study the forces that acting on the knee. Second point here, third point, okay, and so on. The hip joint, fourth point, and the pelvic point. Okay, you can apply a static fundamental, okay, to study this biological system, our human biological system. Okay, but of course, we are in 3D dimension. We are in 3 dimension. Okay. So you have to learn 3D. So 2D is very basic, but 3D is necessary to learn because we are living in the not only 3D but 4 and 5D. Okay, let me proceed to the next slide. Okay, 3-dimensional analysis, 3D. So we do have 2 common axis arrangement as shown in the slide. Okay, the first one is very commonly used. Okay, the left part is very commonly used in our study, where the arrangement, okay, right axis is for x axis, the top axis is for the y, and the isometric axis, z axis, is for the z axis. Okay, so for x we denote as I, y as j, and z as k, right? So another arrangement is like the second figure, the second axis, the second figure at the right part, at the right side. Okay, so you can see the arrangement a bit different to the first one, where it can be looked at as isometric view. Okay, isometric view. Only the y axis is not isometric. Okay. All right. We go to the next slide, which is determination of force components. Okay, this is the basic one. A basic force determination in terms of unit vector. We call it unit vector, I, J, and K. Okay, so I as X, J as Y, and K as Z. So if you do have F, like in this figure, F equal to 10 Newton, okay, pointing on the Z axis, okay, only one direction. So you can state the F, the resultant, okay, the resultant of S is equal to 10 Newton K. Okay, so because the force only acting on the z-axis. Okay, so there is no additional I and J there because the force is acting alone on the z-axis. If you look at the second example here, okay, the force is acting on the plane, okay, is on the plane Y, Z. Okay, so meaning that we do have two components, okay, component for Y and component for Z. So you have to resolve this force into two components, okay, for Y and Z. So you will get this one, okay, you will get this one. It is similar like 2D because it is only involved two axes, Y and Z axis. Okay, so you have to use Pythagoras theorem, okay, to get to resolve the forces. Okay, for the Y component, you will get this one. Okay, where this in bracket is for the cos theta. Okay, for the cos theta. And the second component, which is Z component, is this one. Okay, so finally you will get the resultant of force 6J plus Newton. Okay, so you can write like this as well to minimize the writing. Okay, you can write like this as well. G plus T. Okay, in bracket Newton. Okay, so normally I will use this one to represent the final answer. Okay, the second one, the third one, sorry, the third one, it is not really similar like before, but you can see one angle there, an angle there. So the previous one, we give you the length, okay, the length from 0 until the final length of force. Okay, so for this case, we only give you the length in y-axis, but the angle in z-axis. So similar, you have to apply 2D because the force is on the YZ plane only. Okay, right? So you can use the angle only to calculate the resultant. Okay, you can use the angle to resolve the component, the forces into two different components, like shown in the slide. Okay, right. So of course, this one is sine theta lah. Sorry, not this one. Okay, this component y equal to sine theta, and this one is of course z cos theta. Okay, all right, you will get this final answer. Okay, I think it is very simple for you. Okay, before we proceed to the next slide, is there any question? Is there any question?
No, doctor.
Okay, so if you know, I can proceed, is it?
Doctor.
So that one is only basic. It is like 2D only because the force is on the YZ plane. Okay, we will look at the 3D element later on. Okay, so solution procedure for the 3D, we do have we have three methods. Okay, the first method is first angle method, the second is second angle method, and the third one is coordinate method. Okay, so we look at the first angle method first. Okay, given angles between the force and then three axes. Okay, so meaning that all angles are given. Okay, all angles are given from x axis to the force, from y axis to the force, and from z axis to the force. Okay, so given angles between the force and the three axes, you have to use first angle method. If you found the coordinate, the system like this, okay, you have to use the first angle method to solve the problem, to get the resultant. Okay, so component of force here, you can see Fx equal to F cos theta x. Okay, of course, if you want to resolve this force, okay, this force into x component like this, okay, Fx, okay, you will have this one. Okay, similar like Fy, okay, you have to use theta y, okay, to resolve into Fy here. And similar like Fz, you have to use theta z here to resolve Fz here. Oops, sorry. Okay, so in the end of the day, you will get the final form of IJK form. Okay, so let me repeat. So if you have to resolve into component, you have to apply these three equation. Okay, so if you have that three equation, you will get the final resultant force in term of IJK form. Okay, in term of IJK form. So you substitute the value of Fx, Fy, Fz into this equation. Okay, and of course, if you can extend this equation, oops, extend this equation, okay, you can see that Fx can substitute with this one. Okay, it is very simple, which is only substitution involved. Okay, so you will get this equation. Okay, why we do this? We want to see is there any equation that involved in this first angle method. So if you have this equation, you can simplify this equation into this one. Okay, so you will have F equal to F in bracket cos theta xi plus cos theta yj plus cos theta zk. So you can see the relationship here. Okay, so for the next slide, okay, if you still remember in mathematics, okay, we do have lambda, okay, lambda. So lambda is equal this one, lambda, okay. So we can simplify the equation, okay, the resultant equation into this one, F equal to F lambda. So we know that F lambda is very simple equation, is very simplified equation. Okay, and you have to remember that lambda is equal to cos theta xi plus cos theta yj plus cos theta zk. Okay, all right. So lambda is not necessary to use in any solution in any problem, but you have to remember. Okay, and lambda is unit vector along the line of action. So lambda, if you still remember in mathematics, meaning that lambda is unit vector along, okay, along the line of action. This is the action which is force, okay, and the line of action is coming from the initial point here, okay, initial point here, oops, until in the end of the world, okay. This is the sorry. This is the line of action, okay. Yeah. So that one is lambda, okay. All right. So let us recap again the vector identities. So I believe that you have learned this before in mathematics. So we do have a lambda s equal to cos theta s. Okay. Let me change to laser pointer. Okay. So lambda s equal to cos theta x equal to fx over f. Okay. So you have to remember this relationship. Okay, fx over f equal to cos theta x. Okay, fx equal to f cos theta x. Okay, so fx equal to f cos theta x. Okay, and lambda is equal to lambda x equal to cos theta x. Okay, so I normally remember this equation. Okay, and then you can rearrange the equation according to the needs that coming from the problem or from the solution that you have to do later on. Okay, so and similar like lambda y, lambda z. Okay, so you have to know the basic equation, then you can rearrange the equation later on. And you have to know this equation as well, which is lambda x power of 2 plus lambda y power of 2 plus lambda z power of 2 is equal to 1. Okay, and some cases you will use this equation. Okay, you will use this equation. Okay, and you have to use this equation later on if some problem not having angles. Okay, I will show in the slide later. Okay, so we know that the lambda x is equal to cos theta x. So you substitute into the equation, you will get this one. Okay, you will get this one. Okay, and finally, you know this equation. It is similar like 2D. Okay, it is a resultant. Okay, so this is the example for the first angle method. Okay, if you can see at the figure, there are three angles, theta x, theta y, and theta z. Okay, there is one force only acting on the system, which is 1000 Newton. Okay, so the question asking you to determine the 1000 Newton force in terms of I, J, and K. All right, so the given angle is only two. The first theta x is equal to 135 degree, and the second one is theta z equal to 60 degree. Okay, so the theta y is not given in the question. Okay, all right. So before we can get the resultant, you have to find the theta y. So
use
any
the
idea how? Do you have any idea to find the theta y?
cosine square of x and the cosine square of y, the cosine square of z equal to 1.
Equal to 1. Yes, correct. So you have to use these identities. Okay, you have to use this one. You have to use this one. Okay, you have to use this one. So you substitute the value of the given one into this equation, you will get the theta y on the spot. So this is the example. You substitute the given angle 135 and 60 into the equation, you will get the theta y. Okay, so I will go quickly. Okay, not very specific on the solution. Okay, all right. So if you can see here, there are two values, positive and negative. Okay, okay. So and we choose 120 degree. Okay, so why we choose 120 degree instead of choosing 60 degree? Any idea?
Because in the figure, the line passed the 90 degree.
Yes, correct. Okay, because the force of 1000 Newton is passing 90 degree angle. Okay, I have to remind you, you have to imagine where is the force, where is the location of force. Okay, right. Can you imagine where is the force? Why we choose 120 degree? Can you imagine? Sorry, tak dengar.
No, I don't get it.
You don't get it. You don't get it. The location of force, is it?
Yes. Why 120?
Why? Okay, great. So let me explain a very basic imagination. Okay, let's say this is your tree. Can you see my finger with pens?
Boleh doktor.
Besarkanlah
Dekat situ lah.
kejap, sementara. You can enlarge my face. Okay, so this is your three axis. Okay, this is your three axis. Okay, I can define this axis. This axis is x. Okay, this is y, and this is z. Okay, x, y, z. Okay, x, y, z. Okay, so your force, this is your force, 1000 Newton force. Okay, this is your force. Your force is like this one here. Okay, this is your force. Let me take another pen. Okay, the red pen is your force. Okay, this is your force. Okay, you have to imagine like this. Okay, x, y, and z axis. Okay, so if you want to look at the angle, you have to measure from axis to the force. Okay, for example, for theta x. So your theta x is from x axis here to the force here. Okay, this is your theta x. Okay, theta x. So theta x is 135 degree. So it is more than 90 degree. So if you can see at this view, it is difficult to explain in WebEx. If physical, I can explain in front of you. So basically, this is the thing that I can show it to you. So if you look at this view, you can see, okay, you can see the x. This one x, this one x, and this is the red pen is force. Okay, it is more than 90 degree. Okay, this is the axis. The angle is more than 90 degree. So that's why I put this one 135 degree as shown in the slide. Okay, so this is theta x. Theta x. Okay, theta x. Can you see? Can you see? Can you see? Okay, this is theta x from here. Okay, from here to here. This is theta x. Okay, for the theta y. Okay, for the theta y. Okay, this is y. This is y. This is your force. Okay, you can see the force is more than 90 degree here. Okay, this force is more than 90 degree. Okay, the force is exceeding this axis, z axis. So we can say that the force is more than 90 degree. So that's why we have to choose 120 degree instead of 60. Okay, and of course the theta z is only this one. Okay, this one from red to y axis, from red to y axis. So the theta z is 60 degree. Okay, can you imagine right now?
Yes, doctor.
Okay, is there any problem? So if you want to imagine where is the force, you can use this method. Okay, you put the x, y axis like this using pens, and then you can introduce another pen as the force like this. Okay, and that's why we choose 120 because the force, the angle for the force coming from y axis is more than 90 degree. Okay, so that's why we chose 120 degree instead of 60. All right, so once you have the angle, all angle, then you can substitute all the angles into the equation. Okay, we do have the equation, this equation, okay, this equation, okay, this equation. So you substitute the value of f value of theta into the equation, you will get the final answer of resultant in term of IJK form. Okay. So for this example, you can see every single component have unit N Newton. So if you want to reduce the writing, you can write like this. And to avoid confusing, you can write like this in bracket Newton. Okay, so you can write like this as well. Only put one unit in the end of the answer. Okay, so far any question before we proceed to the next method?
No, doctor.
Okay, seorang jawab ni. Yang lain okey eh? Okay, if okay, then I proceed to the next one, which is second angle method. Okay, for the second angle method, still using angle, but different kind of angle. Okay, different kind of angle. Okay, so given one angle between the force and axis, okay, and one angle on the plane, meaning that for the second angle method, the figure only give you two angles. Okay, two only angles. Okay, the first angle between the force, okay, between the force and axis. Okay, this is your force F and axis. This is axis. This is y axis. Okay, this is y axis. This is the first angle, theta y. Okay, force and axis. And another angle is from one angle on the plane. Okay, we have this dotted line. Okay, and this is the plane, and the angle on the plane, this is the angle. Okay, the angle on the plane. So if you found this type of system, you have to use second angle method to solve. Okay, to solve the problem. Okay, so basically once you have this system, you have to resolve the component, the force into components. Okay, the force of F, okay, into several components. Okay, the first component is of course on the axis y, this one. Okay, we can just say that Fy equal to Fv in this case. Okay, in this case, some cases the force of Fv is not on y axis, maybe is on the x axis or z axis. Okay, for this case, for this example, the Fv is on the Fy axis, y axis. Okay, so another component is on the plane, this plane. This is the plane xz, plane xz. Okay, on the plane. So this is the additional component. Okay, so we denote it as Fh. So Fh, you can get it because you have theta y here. Okay, so using the sine, cos, and tangent equation, okay, using the cos sine equation, you will get Fv straight away. Okay, Fv equal to F cos theta y, and we know that Fv equal to Fy. Okay, and another component Fh is equal to F sine theta y. Okay, so we get Fh and Fv for the first calculation. Okay, and then for the next one, you have to resolve. Once you have the Fh, you can resolve again into two components, component x and component z, as shown in this slide. Okay, So you can get this one is this one is f-ish. Okay, you can use this pi angle, okay, to get z component. Okay, so you will get fz equal to f-ish cos pi. Okay, and then fx equal to f-ish sine pi. Okay, and then you will get the answer for the components. Okay, fy, fs, and fz, and you can get ijk form for the force. Okay, is there any question? Can we proceed to the example 2?
Yes, doctor.
Okay, so we proceed to the next one, next example, example 2. Okay, given this system, you have two angles only. Okay, theta y and also the angle on the plane, 30 degree. Theta y is equal to 60 degree. So the question asking you to determine the 1000 Newton force in terms of IJK form. So you have to use second angle method lah. Okay, because you only have two angles given. Okay, so the first thing first, you have to resolve this force into two components. Okay, Fv equal to Fy. Okay, and this component F-ish. Okay, all right. So using the angle of theta y, you can get the Fv and F-ish straight away. Okay, Fv 1000 cos 60 equal to 500 Newton, and F-ish 1000 sine 60, okay, equal to something. So in this solution, the F-ish remain like this. Okay, to further calculate later. Okay, and then once you have the F-ish, you can get the component of Z, Fz, and also the component for X, Fx, okay, using this theta and using F-ish. Okay, you will get Fx, okay, equal to negative. Don't forget to put the sign because the force acting on the x component is negative. Okay, negative x, positive y, positive z. Okay, and put the sign, and then you have to put fh sine 30. So substitute fh here into this equation, you will get this one, and you will get the final answer of x component, negative 433 Newton. And then for the component z component, okay, fh cos 30, substitute this one into this equation, you will get 1000 sine 60 cos 30, and you will get final answer of the z component. And then you have to write IJK form like this. Okay, this is your final answer. So again, you can write like I said just now to reduce the writing or to avoid confusing. Okay, and put the unit in the end of the final answer. Okay, like this. Okay, so far so good, is it? Very easy, right? No
Okay,
response.
Yes, doctor.
Seorang je respon. Aliyah
Akilah.
Aliyah. Siapa? Akilah. Oh, Akilah. Nur Akilah Shasha. Okay. Alright. Okay, if no question, I proceed to the next one, the last method, okay, for the 3D particles. Okay, so this is the coordinate method. Okay, coordinate method not using any angles for the solution, but we use the length to calculate okay, to calculate instead of having the first one. Okay, the first one consists of three different angles: theta x, theta y, theta z. But for the coordinate method, we use this dimension, which is the distance, dx, dy, and dz. Okay, if you found this system, okay, without any angle given, you have to use coordinate method. Okay, so before we before we use the final equation, let we do some derivation. Okay, let we study on the equation where we get it equation. Okay, so we know that the first thing that we learned just now is about the simplified equation. Okay, which is f equal to f lambda. So you extend the equation, it become f equal to f cos x I plus f cos theta j plus f cos theta zk. Okay, all right. So this is the equation that we learned just now. Okay, so we know that, okay, if you can see, okay, if you can see the figure here, okay, from the first figure, okay, actually we can get the theta, okay, using the dimension dx and dy, okay, or using the dimension of dx, dy, dz, and d, okay, d. So we use this one to get the cos theta, okay, cos theta, because we don't have any angle, okay, we have to use dx and dy, dz, and also d. Okay, so if you look at a triangle like this, okay, a simple triangle where d is the force, okay, okay, let's say d is the force, okay, and d is the axis, okay, right. So for the x-axis, we put it this dx, okay, and d is the y, dy, okay, and sorry, y, and the is dy, okay. So in 2D dimension, okay, you will get this d actually, okay, and this is your theta. So since this belong to x, we can denote it as x, okay, theta x. Okay, according to theorem Pythagoras, you can get v here, okay, and according to the cosine rules, you will get this equation, okay. Okay, can you get it?
Yes, doctor.
Okay, great. So this is the basic things in the coordinate method. So we use this triangle, ds to d, 2D for the plane xy. That's why from this triangle we get this equation, cos theta x equal to dx over d, and same goes to y component and z component. Okay, so we do have additional equation to get the resultant, okay, of d, okay, and then this one is similar like before. So lambda is equal to cos theta. Actually, you just substitute with the lambda, okay. And if you can see, okay, if you can see here, this initial equation, okay, consists of cos theta x, cos theta y, and cos theta z. You can substitute this one into this equation, okay, oops, into this equation, oops, into this equation, okay, and then you will get this one. Okay, you will get this one. So we have additional equation to solve the coordinate one, to represent the coordinate method, okay. And in the end of the day, you will only use this one, this equation, to solve the problem, okay. The top the previous, the upper one is only for the explanation on how we get the equation, and the final one, the final equation here is useful for the analysis. You will use this equation for the for solving the problem. Okay, so you can see that you can find the x component using this one. Okay, dx over d times with force. Okay, dy over d times with force for the y component, and for the z component this one. Okay, all right. So let me repeat, let me recap. Okay, you have this value dx, dy, dz, and then you have to find d. Okay, and substitute the value into the equation, this equation. Okay, you will get the force in terms of I, J, K form. Okay, so any question before we proceed to the example 3?
So far now.
Okay, so far no, very easy lah, straightforward. Lah kacang je. Kalau orang Melayu kata kacang. Okay, so example 3. So you have to determine the 1000 force in terms of I, J, K form. So how to do this? How to do this? Any idea?
Coordinate method.
Yes, of course. So for the coordinate method, what you have to find first?
The D total. The result of D.
Okay, how about dx, dy, and dz? Yes, Rabiul Hassan said that you have to find dx, dy, dz, and of course you have to find the resultant. Okay, so how to find dx? Any idea? Okay, any idea on how to find dx? Ini soalan senang ni. This is very simple question. If you cannot answer this, you will be trouble in the future.
There is 0.6 in the plane. 0.6 and Z is 0.4 and the Y is 0.8.
Okay, wrong. The answer is wrong. So how to find dx? So you have to calculate from initial point of force to the final point of force. Okay, so you can see the force arrow there. Okay, the initial point from here. Okay, and the final point is here. So you have to calculate dx from the initial point to the final. Okay.
0.6 plus 0.5, yeah?
Okay, correct. 0.6 plus 0.5, and the sign should be
Cosine.
the sign, the direction.
0.6, I think minus 0.5.
0.6 minus 0.5, like this. Oh, like this.
Yes, doctor.
The answer is wrong.
Doctor, negative side, because it goes to the negative side of X.
Yeah, and then the answer is
Negative 1.1.
yeah, negative 1.1 lah. Of course, you have to put negative both value like this. So dx equal to negative 0.6 minus negative 0.5. Okay. So you will get negative 1.1. Okay. Okay. So do you know why we get negative? Eh? Do you know why we get negative? You have to think. This is mathematics, not static.
The
This one
force
is
goes to
mathematics.
the negative side of the x, so it goes opposite way.
Yes, correct. So the force, if you look at the x-axis, okay, the force starting from the right part, okay. If you look at xy plane, okay, xy plane here. Oh, xy plane, y plane. Okay, you can see the initial point of force starting from the right part, to the left part. Okay, so meaning that it's moving from right to left. From right to left, meaning that it should be negative lah, because the positive of x is right, and you're moving to the next left part. Okay, negative. So the value of dx should be negative lah. Okay.
Doctor, I want to ask a
All right.
question.
Yes, please.
What is the negative side of z? Where is it?
Okay, if the z-axis, you have to look at this plane, y, z. In this example, the dz is positive. Okay, in this example. But if you have this example like this, let's say the initial point going back like this, so dz should be negative lah. Okay, because here is positive z. The other side is negative. So from positive to negative, the dz should be in negative sign. Okay, so but for this case, the z is positive.
Okay, doctor, thank you.
Right. Okay, so for dy, how much dy? dy, y. How much dy? Think. You have to think.
0.8
Yes.
plus 0.8.
2 meters.
2 meters,
1.6.
yes. No, the answer is 2. And is it should positive or negative?
Positive. Upward.
So the answer is positive. So you have to look at this y, 0.8 plus 1.2. Okay, so dy should be positive. Should be positive 8. 0.8 plus 1.2, because the force from negative part moving to the positive part of y-axis. So that's why we get positive. Okay, positive 2. All right, so should be in meter lah. This one should be in meter. How about dz? How about dz? 1.2. Okay, correct. Positive or negative?
Positive. 0.8 plus 0.4. Positive.
Yeah, correct. So this is the positive one. Sorry, this is the z one, and this is an additional z. Okay. So 0.4 plus 0.8, you will get dz equal to 1.2 meter. Okay, so you will get this one. Okay, negative 1.1 meter, dy 2 meter, dz 1.2 meter, and you have to use this equation to find d, and then you will get d, and then substitute this value into this one, and this one. you will get the final answer all false in terms of IJK form. Okay? Easy, right? Easy, right? Kering, 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 kering. Respon sikit. Oh, okay.
Yeah, doctor.
Yeah, easy
Yeah,
lah,
betul.
easy. So many people, many students say that static is very, very difficult. But for me, it is very easy. Not so easy. Easy lah, Rabiul Hassan. Easy, very easy. You have to set into your mind, say that this subject is very easy, the easiest subject in the world. Okay, so okay, just to remind you, there are many mistakes from student. Okay, in this part. Oh. In this part. Okay, in this part. There are many mistakes from student in this part. Some student wrongly set the sign positive and negative. Okay, so you have to be careful to calculate the total D, including the sign positive or negative. Okay, if you wrongly set this value, the rest of calculation here will be wrong. Okay, will be wrong. So you must make sure, you have to make sure that the first value dx, dy, dz is correct. So if wrong, then the rest is going wrong as well. Okay, so I just want to remind you. So there are many mistakes from student for the first part, which is to determine dx, dy, and dz. Okay, resultant. Can we proceed or you need to take a break? Okay lah, take five, take five. Okay, 5-minute break. So we will resume in 5 minutes later. 9:20 we will continue. Okay, 5 minutes break.
Okay, Doctor. Thank you.
Okay, doctor.
Okay, 5 minutes Pergi minum je, jangan pergi makan. Okay, so let's continue. Are you still there?
Yes,
Yes,
doctor.
doctor.
Okay, so let's continue on the next one. Okay, 3D analysis resultant. Okay, so just now you learned how to resolve into X, Y, and Z component. So this time you will learn on resultant. Okay, resultant, as you know that the resultant is the total force. Okay, the total force for all forces. If you have more than two force, if you have two and more forces, then you have to calculate resultant if the question asking you to do so. Okay, so resultant is the total forces. In the simple word, is the total force. Okay, so basically, yes, you have to sum up the component. You cannot sum up X and Y component together, but with the same component of X, for example, okay, you can sum up like this. Okay, all right, the total forces in X component, the total forces in Y component, and the total forces in Z component. Okay, easy, right? Easy, just a sum up. Okay. Okay, like this one, if you have two forces on the system, okay, and then the question asking you to find the resultant, then you have to use the resultant equation. Okay, so basically you have to do you have to provide x, y, z component first before sum up everything. Okay, so if you can look at this example 4, you have two different force. F1 equal to 450 Newton, F2 equal to 750 Newton. Okay, and then you have to resolve F1 into K form, and similar goes to F2 K form. Okay, so I believe that you can do this one. Can we do together?
Okay, doctor.
Yes, doctor.
Right. So for the first force, which method that you have to apply?
Second angle method.
Second
Yes,
method.
correct. So you have to get IJK form first for the first force. So yes, you have to do right now. We do it together. You have to resolve in Y component for FV and Fy, and then the component on the plane, okay, F-ish, and then you will get Fx and Fz later on. Okay, can you do it now? How much for the Fv or Fy? Okay, so how much?
450 cosine 50.
Yes. Sorry?
450 cosine 50.
50. Okay, the answer is the answer is
289.25.
yes, correct. So how about Fh? Fh, how much Fh?
344.72.
Okay. And how about Fx? Fx and F
298.5.
298.5. Okay, oops. Yeah. Okay, so basically, if we have two forces, then you can set F1x because this one is Fy, F1y, okay, Fyz, okay. So how much for the F1z?
Doctor, the Z here should be negative, right?
Which one?
Here, in this force.
Which one? Which axis?
The Z1.
Huh?
The Z, right or no?
Yes, the Z should be negative. Yes. So you have to consider the negative and positive sign as well. Okay.
Negative.
So
Wow.
the Z is minus 172
4.
point
0.4.
yeah. Oops. Okay. So let me check if you don't about the sign, about the positive and negative sign, you have to check after you got the value. Okay. So let's say you got the value y is 289, x is 298, and z is 172. So you can check. Okay, you can check here. Okay, this force, if you look at x-axis, it should be positive because it's from the origin to the positive side, and this is the correct. This is correct one. Okay, if you look at y-axis, it's from origin to the positive one, the positive one, meaning that the y value should be positive. Yes, correct. But for the z-axis, if you look at the initial point there to the back side of z component, okay, this one is positive. Okay. Okay. So you can see the force is acting on the back side of z-axis. So meaning that you have to put negative. Okay. This one is the way to check your sign, your negative or positive value. Okay. So yes, you got the value, then you have to write down in term of IGK form like this. Okay. Write down in term of IGK form like this. Okay. Make sure that the sign should be correct. Okay. The sign should be correct. So this is your final answer for F1. Okay. F1. So how about F2? What method that you have to use?
Coordinate, Doctor. Coordinate.
Yes, coordinate method. So for the coordinate method is very straightforward. You have to determine dx, dy, dz, and d. Okay, so how about dx? How much dx?
Negative 1.2.
Yes, correct. Huh? Okay, dy
1.2.
1.2.
Positive.
1. Yeah, positive. And dz?
0.6 positive.
Okay, correct. So how about d? D, you have to do it right now so we can have the discussion.
1.8.
1.8, is it similar like others? Okay.
Yes, yes,
Well,
doctor, correct.
all right. So you have to substitute the value into this equation lah. Dx over d for I, and so on. Okay. Oops. Okay, this one. Okay, substitute the value into this equation and this value into the equation. Okay, f we already know, then you will get the answer of f2 in terms of IJK form. Okay, and again, if you want to check the sign positive or negative, then you can check again on the original figure, okay, we can see from here, we can see that the only negative sign is for the x1, okay, for the x, okay, and for the y, this one is the false, for the y and for the z is positive, but for the x is negative. You can check like that for the final answer, okay. So you will get this final answer in terms of IJK form for F2. Okay, do you get it? Do you get the same answer?
Yes, doctor.
Okay. So for the resultant is very straightforward. You just add up everything. So you have F1, F2 in terms of IJK form. Okay. Make sure that you add up the component, the same component, and this one. S should be X with X. Y should be with Y. Okay. Y should be Y lah. And Z should be Z. Then you will get the final answer of the resultant. That is your final answer. Okay. So again, you can write like this. Plus 7.6 K. Bracket Newton. Okay, you can write like this to avoid confusing. Okay. Any questions so far? Easy, right? No, doctor. Only one response. Daniel Hakimi, no. No.
No, that's
Tak ada soalan. Tak ada soalan. Okay, tak apa. So, if you don't have any question, so I think we have to do some exercise. Okay? Are you ready, guys, for doing exercise? Can we do exercise? The answer is given there. Can you do it right now? Okay. So let's do it together and together. So you from the system, you can see there are three forces. Okay, F1, F2, F3, and in each one, you have to use different method to solve to get the component. Okay, so let's do it together. You have to prepare pen and a sheet of paper. Okay, do it together. So this is the time to practice. Dengar ke tak ni?
Dengar doktor.
Dengar doktor.
Ada.
Dengar doktor.
Ingatkan saya cakap seorang-seorang tadi. Okay, do it now. So the answer is there. The total resultant is there. Do it now. Do you get the answer? Okay, how about F1? How much? Oops. F1, F1, F1. Can someone tell me the answer?
D equal 11. D equal 11.
Okay. And the answer for
D
F1?
X F1 still calculating.
Okay,
DX.
skill testing. So I can see some answer from one student. Okay, let me check the chat. How to check the chat? Okay. So Wong said that the answer is 154. Oops. 4 I minus 132 G plus 132. Right. Okay, so this is answer from Wong Kin Tong. So this is the answer for F1. So everyone, please check your answer. Is it same or not? If not same, please say here. Okay, Junaid said yes. Same. Okay, how about F2? What is the answer for F2? F2 still calculating. Maria Alessandra, where are you from? Oh, Philippines. Okay. So you are now in Philippines. What time there? Same time zone. Okay. So meaning that now is 9:30 a.m. as well. Okay, right. But I believe that sunrise is more is not similar like Malaysia, right? So I believe that maybe around 6 a.m. is the sunrise, is it? Okay. Similar like Sabah lah. Okay, guys, F2. What is the answer for F2? Okay, Lee Jianwen said that negative 64.95 I, okay, plus 75 G plus 112.5 K.
Doctor,
Yeah. Is it same?
for F1,
For F1, what's wrong?
the Z, should it be positive or negative for the Z?
F1.
Because it's left.
F1, the negative one is only for the Y component. This one is correct.
Why the Z is positive? It's
Which
in
one?
the left side. The Z. It's
Which
the
component?
left side.
Which component?
F1Z.
Yeah, I know. Which component? X, Y, Z?
6 meter.
Okay. If you look at this force, okay, from my view, the negative sign is only for the Y, because what? If you starting from the origin, the force is going downward like this. Okay, so if you look at Y axis, from origin to downward should be negative lah. Okay. If you look at the other side, which is x-axis, okay, you can see the angle is going to positive as well. So meaning that it is positive, and z, and Z should be positive as well. From origin to this side, okay, this positive, okay, and this one is X. And this one is Y. So this one is positive, and negative. Okay.
Okay, doctor, understand. Thank you.
Right. Okay, so F2, did you get the same answer? Yes, Daniel Hakimi said yes. Yours, yes. Okay, let's proceed to the F3. So how about F3? How much for the F3? Oops. F3. Yeah, you know what? When I teaching in synchronous like this, I cannot see your faces, of course, and I cannot see your writing or your solution in front of me. So difficult for me to choose person to give answer. So basically, you have to actively involved in the online class. You have to provide answer lah. No need to wait until I call your name to give answer. Okay, Wong King Tong. The answer from Wong is 86.6. Hai. Dah tak betul dah laptop saya ni. Lama sangat kot. 50. J. Okay. 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 So the answer is here. The answer is here. So basically, if you want to find the resultant, of course, you have to add up all the component value. I mean the same component value, the same component for the same component. Let me. Okay. So for X component, you add this one, and this one. You will get this answer. Okay. And for Y component, you add this one, and this one. You will get this answer. Okay. And the last one, the Z component, only 2 Z component for F1, F2 only. So you will get this answer. Alamak, kenapa tak boleh ni? Okay. Alright. So can you get the final answer of resultant? Is it same or not? Okay, got it. So Maria said got it. Okay. So this is the way that you have to calculate. Okay. You have to calculate one by one to get the IJK form for all forces, and then you can get the result later on. Okay. All right. The time now is 9:44. Are you okay if we continue? Are you okay if we continue? All right. Yes. Okay. The last one before we end the class. Okay. And this section will be covered in next class. Okay. Will be covered in next class. Okay. Let me check. Okay. Only a few slides left. Okay. So the last one before we end class for today is exercise 2. Exercise 2. So the previous one, the previous exercise, we do have 3 forces only, but this time we have 4 forces. Okay, so you have to find the resultant. in terms of IJK form? Can you do it right now? Do it right now. Wait, give me some time to do something because my laptop is lagging right now. Okay, so do it right now. Exercise 2. F1, of course, you have to use second angle method. F2 using the first angle method. F3 using the coordinate method, and F1 is straightforward. F1 no need any method to use. You can get the straight IJK form for F4. Okay. So do it now, do it now. I want to see the answer. Okay, so what is the answer for F1? Okay, for F1, I can see that the value for X component should be negative, the value for Y component should be positive, and the value for Z component should be negative. Okay, so only one positive, which is Y component. Okay, 2% give same answer. So the answer is 6 points. 66.34 I plus 50 J 55.67. Okay. Okay, so this is your answer for F1. Please check either correct or not, either same or not.
Doctor, I get F3.
Sorry, which one?
F3.
You get F3.
Yes, doctor.
Okay, how much F3?
268.33 I.
Sorry, 2,
68.
68, sorry, 68
Point 33 I.
Okay.
Plus 80.50 J.
15.
No, 50. Sorry, doctor.
Okay. Wait, yeah.
Minus 107.
107.
0.33 K.
Okay. So everyone, please check your answer. Is it same or not? How about F2? So F4 is straightforward. it is only one component, which is x component only. F4 is minus 100i Newton.
Doctor, I want to ask a question.
Sorry?
Yeah, I want to ask a question.
Yeah, please.
The angle between y and x is 90, right?
Which one? F2, is it?
No, I mean, yeah, I want to ask you that what is the angle between y and z and x?
Again, your question?
What is the angle between y and z and x?
Z and X. Which force that you refer to?
No, in general. Because, you know,
In general.
y and x, the angle between them is 90.
Actually, I don't get your question.
He mean the axis, doctor, between y and x.
The axis Y and X.
Doctor, in the plane, in general, the angle between y and x is 90, right?
Yes, correct.
So what is the angle between y and z? And also z and x?
Similar, 90 as well.
90?
90, 90. Same, 90 degree as well. Do you mean this angle, is it?
No, yeah, this is 90. I mean between z and x. But doctor,
Also same, 90 degree. This angle is also 90 degree. It is an axis. It should be 90 degree lah, to each one. I think you are confusing because of the arrangement. Okay, maybe you look at this one is not 90 degree, but supposedly it should be 90 degree lah. This one maybe you look at more than 90 degree, but in slide we can not see the 3D very clearly. Okay, but of course the angle should be 90 degree from each other. Okay, Hussein, you get it?
Okay, doctor, thank you.
Okay, so all angles should be 90 degree. From x to y, y to z, z to x, z to y, and so on. Should be 90 degree. Okay, how about F2? F2. F2. Oh, no one? F2?
In the chat box, doctor.
Oh, in the chat box. Okay, sorry. Okay, so there are two person give same answer. Bincang ke apa ni? Bincang kan? So the answer for F2, you have to check either correct or not. Oops, again, it happen every time I write. Minus 100 G plus 100 K H. Okay, so please check the answer. Is it correct or not? And please check also the answer for the final resultant. So you have to sum up the x component. Okay,
X
sum up
correct.
everything. Then you will get this one. Okay, somewhere get it. Do you get it?
Yes, doctor. This one is correct.
Okay, y component. Oops. Okay, one component Okay, you will get this one. And the last one is Z component. Okay, and you will get this answer. Okay, is it same?
It's all correct, doctor.
Same. Okay, great. Okay, so far so good. Easy, right? Easy lah. Okay. So the static subject is very easy. The easiest subject in the world. Okay. The easiest subject in the world. So don't worry too much. Inshallah, you will get A if you do a lot of exercise. Okay, because a static you have to do a lot of exercise. This is not memorizing a subject. You have to practicing. Okay. So if no question, is there any question?
No, doctor.
No,
No,
doctor, thank you.
Right. So I think that's it for today. But before we end the class, I just want to know, is it okay if we do some tutorial class? So during the tutorial class, we can do exercise together. Is it okay for you?
Okay,
Yes,
doctor.
Doctor.
Okay, if okay, then in the group later on, I will suggest time and day. So you can pick any time that you think that suit to you. Okay, so I will inform in the group later on. So I believe that we have to do some tutorial, so to make sure that you are familiar with the subject. Okay.
Doctor, thank you. Doctor, but please can you upload this file after the class?
Hussein, sorry, I cannot hear you clearly. Can you repeat again?
Can you upload this file after this class?
Yes, sure. Every time, every class, I will upload the lecture note and also the recorded lecture. Okay.
Okay, doctor, thank you.
Okay. If no other question, I think that's it for today. All right. Thank you so very much, and see you on Wednesday. Okay. So, bye, 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 bye.
Thank you, Doctor.
Right. All right. Okay. Okay.
Thank you, Doctor.
Okay. Bye, bye. Siapa suara tu? Nampak macu ah.
Thank you, doctor.